Hi, my name is Brice Bucher. I'm the head of product here at Fluxware Innovation. And today I want to talk to you about AGV and AMR software. So one of the biggest trends that we've seen in the automation of intralogistics is the introduction of autonomous vehicles and mobile robots in order to be able to start to automate processes. When we talk about intralogistics, we're talking about the movement of materials and items inside of the four walls of a facility. So AGVs and AMRs are one of the pieces of technology that's being used to automate that process. Now, what we're seeing is the emergence of software around those autonomous vehicles that tends to repeat itself from one project to the next. So obviously, when you are implementing these vehicles into your environment, there's going to be software on the vehicles themselves. That's kind of a fourth category of software we're not going to get into today. I really want to focus on the higher level software that is used to connect the vehicles into the surrounding ecosystem of your environment. And really, we're seeing the emergence of three classes of software. And I want to go through each one of those to help you understand a little bit more about how they play a role in the automation of all this process. And when we talk about the surrounding ecosystem, we're really talking about the equipment and the systems that exist already inside of your operations that you're going to need to be able to connect to in order to be able to communicate effectively with all of these vehicles that you're implementing. So we're talking about things like PLCs on your equipment, doors and elevators that the vehicle is going to have to travel through, SCADA systems out there on your shop floor, MES systems, WMS systems, ERP. The list goes on as far as the systems that you're going to have to interface with. So we're going to try to connect all those systems in with the vehicles that we're implementing. So the first class of software that we see in this space is fleet managers. Now, fleet managers are higher level software that communicates down to the vehicles, and they're very good at really two things. And the first of those is route planning. So how do I get from point A to point B? And traffic management. So making sure that there's no congestion or obstacles in the way. They'll route vehicles around other vehicles, etc. So the fleet managers communicate down directly to the vehicles themselves and allow those vehicles to be able to get from point A to point B. Now what we're seeing is three classes of fleet managers being implemented as well. I'm going to just very quickly go through these. So the first one of these I'll call the single vendor fleet manager. And as the name implies, typically they communicate with one fleet of vehicles from one provider only. Now this doesn't mean that it's just one style of vehicles. That vendor might provide forked vehicles as well as underride vehicles, but they all have the same control software. They all are using the same fleet manager, and you're constrained to just that brand of AGV or AMR. So that is your most limiting option when it comes to fleet management. There's another type that I'm going to refer to as multi-vendor fleet manager. And in this particular case, you can support multiple fleets, and those fleets could be from different vendors as well. Now, one of the traditional caveats to this style is that those different fleets had to operate off of the same vehicle control software. So even if you were combining two different vendors together, they still had to use the same controls on the vehicle itself. That's starting to loosen up a little bit. I'll get back to that here in a second. So that kind of leads us to the third category of fleet manager that I'm calling global fleet managers or centralized fleet managers. And these are the most agnostic, and as the name implies, you can support multiple fleets, and they do not necessarily have to be operating with the same control software either. But the one constraint here is that most likely they're probably abiding by one of the standards that is emerging out there. VDA 5050 is the most prevailing standard, so most likely these fleet managers are using that standard to be able to communicate to all of these different diverse fleets together. And what we're also seeing, back to the multi-vendor fleets, is that they're starting to open up and adopt these standards as well, which kind of blurs the line between your multi-vendor fleets and your global fleet managers. And probably those are going to converge, and there's not even going to be a difference between the two as you're moving forward. So that handles the majority of your autonomous vehicles, but there are still a couple of things that are missing here. If you're trying to track all of the vehicles in your facility and connect them back into your ecosystem. So there's a couple of holes here. So one is your legacy fleets. And by legacy fleets, I'm talking about older AGV typical style fleets that may have been in place for a couple of decades. They don't have very sophisticated software APIs or interfaces to them. They tend not to communicate to the outside world that well. They don't support these new standards that we just talked about. So they're kind of like a black box and very difficult to interface with or integrate with, but they are still interoperating physically in the same environment in some cases as your newer fleets are. So we have to be concerned with them, and if possible, be able to track them and be able to control them to some degree so that we can interoperate safely. And the other sort of missing piece is what I will call your manual fleets. So these are your work trucks, tuggers, reach trucks, things that are still operated by humans. And obviously there's no automatic tracking of those being done either. So we've got a couple of different types of fleets that we still need to be able to integrate in with the rest of our systems. So this is where the second class of software comes into play, and this is what we refer to as real-time location services, or RTLS. Now this is a class of software that is fairly mature. Some of these providers have been around for 2 decades or more and are on their 3rd or 4th generation of software. So it's a very mature offering, but it matured and grew up by doing mostly item tracking, is where it excels. So we have items. Think about this as, materials, assets, could be people, that are tracked in real time, typically through some sort of RF technology. So you've got RFID, Bluetooth, UWB. These are different RF technologies that are used to be able to locate these items. You typically put RF tags on your items, and then you have fixed sensors that are mounted throughout your facility that are then tracking the movement of these RFID tags that you put on your items. That's how these things traditionally worked. But obviously there's a new use case here that can leverage the power of these technologies when you talk about our legacy fleets and our manual fleets. Because if you already have an RTLS system in place, you could put your RF tags on your manual fleet trucks, as well as your legacy automated vehicles, and then that would allow you to put location data up into RTLS and then port that over to your fleet manager, and you can get everything into one system that way. So that's one option. Now, if you don't already have an RTLS system in place using those fixed sensors, which happen to be very expensive to implement, then there's newer ways that these companies are finding to be able to track these other fleets, and that is through the use of SLAM or VSLAM technology. This is localization technology that is very similar, if not identical, to how autonomous vehicles operate. So the technology is now on the trucks themselves. So instead of having tags added and then being picked up by fixed sensors, your technology or your kit is on the truck itself or vehicle itself and localizing itself and reporting its location back up into the RTLS software. So it's a way to be able to, without a lot of infrastructure cost, be able to start to track location on these other types of fleets. So now we've got all of our vehicles kind of into a software layer that can talk to one another. So it feels like we're close to being done here because we're able to talk to all the different vehicles and robots that are moving items around. But there's still a really big gap here. And that gap is, how do we connect to and communicate with our ecosystem? So that is where the third class of software comes in, which is what we call orchestration. You may have heard this word being used a lot lately when it comes to intralogistics. And it just so happens that FlexWare's Lift platform is an example of an orchestration software platform. And orchestration software is really good at two things. More than two, but the two primary things are integration, so the ability to connect to all these systems, different protocols, different communication portals, APIs, etc. I'm very good at that, and it's very good at business logic. So it's, once you have this data from all these systems in, you can start to use that data to drive real decisions, to handle exceptions as they come up, edge cases, etc. So the real sweet spot here is right in the middle. If we have all this data from these external systems, all the data coming in from our vehicles, then you can start to achieve this concept of physical AI, which is this intelligence layer that allows our robots and vehicles to start to interpret their physical environment and start to behave at least as good, if not better, than the humans that are doing these processes now. So hopefully this helps clear the air a little bit about the major pieces of software that are involved typically in these large intralogistics automations projects. And you don't necessarily need all three of these for every use case or every implementation, but what you'll probably find is that you start to scale out across a site, and especially as you start to scale from site to site across an enterprise, you're going to most likely want a holistic solution that has a foundational core to it that is made up of these three components. And then your stuff around the edges is going to change. You're going to have different vehicle systems from site to site, different MESs and WMSs, etc. But if you can keep all the stuff in the middle as standard as possible, it allows you to lift and shift and reuse as much as possible, which really improves your scalability. So that's it for today. Thank you for joining, and we'll look for you on the next video. Thank you.